Okay. All right. Well, first and foremost, thank you everyone for joining us, taking some time out of your day. Today, our discussion is going to be scaling Signal R apps using Ncash backplane. This is the first time we're doing. Well, actually, second. We did the first one yesterday for our European audience. So this is the first U.S. Webinar about the Signal R backplane. It's not a new technology. It's been around since 2014. However, we've a lot of our customer base is using Signal R. It seems it's increasing in popularity. So we wanted to discuss the new addition and some feature adds to Ncash to help the scalability of Signal R applications. My name's Adam Keller. I am a certified Scrum product owner and the director of service delivery here. So in layman's terms, I am the liaison between customers and our engineering team. With me is my associate Ron. He is our lead solutions architect. Ron has well over a decade of experience building enterprise applications. He's very hands-on with our customers, whether it's for technical assistance, demos, configurations, webinars such as this. But due to his interaction with our customers, he's very pivotal as far as the strategy and roadmap of where we take Ncash. So you're in good hands today. You'll see on the GoToMeeting pane, there should be a questions tab. If you have any questions whatsoever, please ask. I'll interrupt Ron and make sure we get all your questions asked. That's what we're here for. So with that, I'm gonna pass it over to Ron. Take it away, and let us know if you have any questions. Thank you.
Very good. Thank you, Adam. Thank you for the introduction. Everybody, my name is Ron. I will present Ncash topic today, and the topic that we've chosen today is Signal R apps, how to scale out Signal R applications, and we'll be using Ncash as a backplane for this. And in this particular webinar, the agenda is that we'll talk about Signal R as a technology, its use cases, how you scale out, what are the issues that you get with scalability, what are the options that are presented as a default option. Backplane is a terminology for that, so we'll talk about the Signal R backplane. What are the issues, what are the bottlenecks within the backplane once you scale out, and then there's a solution which you use as a backplane, but what are the issues with that solution itself. And then we'll present what are the alternatives that you can use with the help of distributed caching. So I'll be using Ncash as an example product. I'll be covering all the details that you need in order to set up Ncash as a backplane for a Signal R application. It's a hands-on webinar, so I'll cover all the details that are needed in order to equip your applications to start using Ncash as a backplane. And we'll talk about what are the benefits that you get towards the end as well. As Adam has mentioned, this is going to be a very interactive webinar where you can also post questions. Adam is going to keep an eye on it, so please keep them coming. So let's quickly get started with this. First of all, I introduce what Signal R is. I've copied some definitions from Microsoft official documentation. So Signal R is a new library for your developers, and this helps you introduce real-time web functionality within your ASP.NET applications. A nice thing about this library is that it exposes functionality, and you don't have to worry about the transport layer. So transport layer is built into it. So all the exchange of messages, those are going to be governed within the Signal R library. So your application just needs to introduce the Signal R resources into the application and start making use of Signal R methods to get started with it. Typically, where you would use Signal R, it's to enhance your user experience by putting real-time web functionality within your application architecture. So it could be any sort of application which is pushing a lot of new content, and typically your user refreshes the page to see the new data, or there's a long polling implemented that helps users to review the new data, right? So that's the kind of use case that you can use Signal R where it becomes a candidate where Signal R can be used, where instead of your clients requesting some new data based on the request and response model, or based on the polling, and again that turns into a request and response model, server can invoke those methods, right? So server can call functionality from the client end through JavaScript, through browsers, and that new data can be made available, right? So server can push client-side code from the connected clients, and data that server needs to push as part of that functionality is going to be made available instantaneously. And this is what helps you achieve the real-time web functionality into your application architecture. And we'll talk about some use cases as well. Now, I've already mentioned that SignalR handles all the connection management internally. So it automatically and simultaneously manages everything. Behind the scenes, it uses the WebSocket. As you know, that HTTP protocol, it's a request and a response. There isn't any connection which is a long-lived. So there is a short connection which gets which gets its lifespan completed as soon as the response is completed. So there isn't any connection. So it's a completely stateless protocol, and so are the connections. But with the help of SignalR, you can utilize the concept of WebSockets, and that's from HTML5 onwards. If you have that, you can use WebSockets. And that's by default. And if you don't have WebSockets, it would automatically fall back to the older transport where it's needed. And you can even check which transport your application is utilizing to all the connected clients. Now, coming back to the transport, it actually opens a connection to the end clients, thin clients, where JavaScript or HTML or your browsers are trying to execute the SignalR logic. So there is a connection between your web server and your thin clients, and that's how SignalR invokes server-side functionality to be pushed, to be invoked from the client end automatically as soon as there is a new data, new functionality that you want to push. So that should cover some basic details on what exactly SignalR is, what are the benefits. Here is a diagram, again copied from Microsoft documentation. So we have a concept of hub, and then there is a client, which could be HTML, JavaScript browser. That's what is representing it, and then these are connected through WebSockets or any other transport. And here you have my client func, which is being invoked from the server end, right? And here we have a server invocation from the client end, right? So server can invoke client methods, and then clients can invoke server methods with the help of SignalR, and everything is part of this. It's a very popular product or popular project. It's open source as well, so there are 200 lines of code that you can review and see what exactly is happening behind the scenes. So this is what we'll be covering, and we'll talk about some of the bottlenecks, some of the issues when you plan on scaling out. I'll talk about some applications based on industries, based on the use cases. What sort of applications would use SignalR, or what are the candidates? It could be chat systems. That's an example that's available on Microsoft documentation as well. Microsoft is also providing one of the samples within their tutorials that also represents the chat system. So which I'll be using as well. So it could be real-time messages, notifications, user management, logging in, logging out. So that's sort of information that you don't want your users to wait, and there isn't any way you can request and respond, or get a response, or there's a polling. It should be made available instantaneously. A new message comes in, you need to be notified about it. It could be gaming industry. That's another use case. We have many clients which are from the gaming industry, and if there is an ASP.NET application, a web application, and other than conventional options such as session caching, view state caching, or to improve performance, to improve user experience, SignalR is another alternative for that, or one of the options for that. Multiplayer games, tournaments, listings, their synchronization, it can be pushed through SignalR wherever there is a need for that. Airlines booking systems, real-time bookings, trackings, ticket availability, new flight data needs to be published to all the clients which are viewing the application at any given point. It could be stock markets, financial sector, stock tracking, stock tickers, prices. So that's another candidate. And then the most, that's something that I personally like quite a lot. Second screen content. You have a main application, but there is a second screen that takes care of any advertisements, push ads, polls, notifications. So any sort of side screen content that you need to push without your user going through a request and response model or polling. It needs to be pushed automatically as there's a need of new data to be pushed. You can use SignalR for that. And finally, it could be Internet of Things. For example, devices that you need to monitor, control, or stream data between those devices. You can, and if there's a web application for it, you can use SignalR for that matter. So these are a few of the message related or SignalR related use cases. They're real-time systems, and you can quite easily use SignalR, and you would see the improved user experience for all the connected clients. Now, next thing that we'll cover, and that's the main focus today, when you plan on scaling out a SignalR application, basically you can create a web form. So let's discuss what are the issues when you create a web form. So this is a typical web form, ASP.NET. You can also have a web garden scenario here, but typically let's focus on web form. You can typically put a load balancer in front, and then you can route requests to all the web servers that you've created within the web form. Now with SignalR, we've discussed that there is a WebSocket connection between a client and a server, right? So when you create a web form, right, so in that case, client A may be connected to this server, client B is connected to another web server, and client C can also be connected to another server. Or there could be 3 clients which are connected to server 1, and then there are 3 clients which are connected to server 2 at any given point. So what are the issues with that? The main issue is that when SignalR pushes or invokes some functionality to be on the client end, it would only do it for the currently connected clients. But since there are multiple servers and there are multiple of those clients, and these clients can grow in number, there are chances that a lot of those clients have been missed because other web server has its own respective client. So each web server sends notifications or messages for invocation of the methods through SignalR to only its connected clients through WebSocket or whichever transport layer it's using behind the scenes. So that's the main problem, that you would not have a consistent user experience from all the clients which are connected. So for example, let's take an example of chat system, right? So from here there was an invocation of a message, and it got received to all the clients which are connected to this web server, but they would not be received by this web server to the clients which are connected to this web server, because this did not invoke that message. So for logic which was executed, which was making use of SignalR behind the scenes, would actually give you an inconsistent view as far as for the connected clients. So that's the main problem with the SignalR scale out, and this is something that a lot of Microsoft pages documentation covers in detail as well. So solution to this presented by SignalR is the use of backplane. Now this diagram illustrates what a SignalR backplane is. It's a shared bus. You would call it a shared repository. It's a shared resource where all your web servers are connected, and they have their own respective clients. That's not a problem, and there's a load balancer in between as well. Now these web servers, instead of sending messages to their own respective clients, if you have a web form configured, and you can use a backplane as well, and we'll talk about options which are available and what are the characteristics of backplane in a bit. These web servers, instead of sending messages or invoking methods to their connected clients, they can actually send that message to the backplane, and that would in turn broadcast this message to all the web servers. So backplane has all the web servers connected. So that is to start off. That's the first rule, and then based on that, whichever web server is going to invoke a method is going to send a message through SignalR. It is going to be sent to backplane instead of their own clients, and then backplane transmits it to all the connected clients. And for real-time applications, we'll discuss what are the issues with backplane and what are the characteristics that you must have within the backplane. So that's how scaling out is managed within SignalR applications, where there are multiple web servers, say 10 web servers, and we'll consistently use 10 web servers as an example for our web form. And if you have a lot of clients which are connected to their respective web server sends messages to the backplane. Here is a delivery of message which is broadcasted to all the web servers, and that in turn is broadcasted to all the connected clients. And that's how you achieve the consistent view and scalability factor within your SignalR application, and at the same time get a consistent user experience from all the connected clients. So this completes our discussion around SignalR, its basic architecture, its use cases, its scaling out issues, and a solution which is presented by SignalR itself. Any questions so far?
Yes, I do have a question. So how does this apply with SignalR for .NET Core 2.1 was a question.
All right, I believe this question is more focused on Encache's backplane for .NET Core 2.1. So Encache official support for .NET Core is going to be made available from version 4.8 onwards, which is going to be released in 2 weeks from now. So it would be on the same lines. As far as ASP.NET Core is concerned, you can use Encache as we speak. That's available right now. But as far as .NET Core framework is concerned, Encache would give an official support for that from version 4.8 onwards. I hope that answers your question. All right, so coming back to the characteristics of a SignalR backplane. So what are the based on this implementation, what are the requirements that a backplane must have? Typically, you can use database for backplane. There could be a central repository such as a message bus, or it could be a distributed caching product like Encache. And I'll talk about why Encache is a better option in comparison, because what are the characteristics that you need as a must within the backplane. So we already discussed that this SignalR is going to be used within the real-time applications, right? So what are the requirements of real-time applications in general? You need a better user experience. How would you achieve that? You need a very fast and very reliable system to hold all the data or all the transport that you need within the application. So first characteristic is that this backplane, since it's now dealing with lots and lots of messages to all the web servers which are connected, and those web servers are in turn sending it to all the clients. So this backplane, which is the backbone of this whole architecture, has to have less latency and more throughput, and that would just combine the performance aspect of it. So performance should be super fast as far as receiving a message and sending that message on to. So latency, the amount of time it takes to process a message received from one of the web server, and that is broadcasted to all the connected clients. So that needs to be done in less time, as much less as possible. So as low as much possible the latency is, you would have better user experience. Now that's just one end of it. The second requirement of the SignalR backplane, and again that's associated with the performance, is the throughput. You need to maximize your throughput, because now your SignalR backplane is dealing with lots and lots of messages, because it's a real-time data. So one dimension could be that your server invokes lots of messages, and if there are, say, let's take an example of 10 messages through SignalR, and there are 10 connected clients, 10 web servers, so 10 into 10, 100 messages at any given point. What happens if those messages are not 10, they are 10, 100, 1000, 10,000, 100,000. So you need to have a scalable system to map that, because it's going to be 100,000 into 10, 1,000 into 10, or 10,000 into 10. So that's always going to be a factor of 10 based on the number of web servers if you have 10 web servers. So it needs to have high throughput requirements fulfilled out of it as a backplane. So database, typical deployment for SignalR on-prem is a database. You might want to use a SQL Server. So database is slow to start off, and it cannot scale out with increasing application load, right? So when your application load grows, and specifically if it's a client invocation of server methods, and at that time it could be lots of clients which are invoking. So in that case, Microsoft documentation, I've read on the tutorial that for that kind of use case, it's discouraged to use the backplane where you have high transaction. But that's something that I totally disagree. For real-time applications, if you need high throughput, you need to have the system to support that. So database is not the system that can help support. It's slow, and it's not very scalable when it comes to increasing application load. And I'll talk about what are the solutions. I'll talk about Encache backplane, and that should help you understand that how it's able to handle more throughput and less latency. Second characteristic of a SignalR backplane, its apps should have a guaranteed delivery of messages. A message should not be lost, right? And there isn't any there isn't lots of stress on this point, but for me personally, coming from a background where we have a real-time application, and if it's a mission critical application, one would discourage using of SignalR backplane, but I would recommend that you should have a system within the architecture that can support reliability and guaranteed delivery of messages. So it should be reliable, which means it should not have any downtime or missing messages, and at the same time all messages should be sent in a timely manner, and that links it with the point number one. So it should be guaranteed delivery of messages. And again, database can tend to choke down, and this is again associated with the load. If the load grows, your database is under stress, or the backplane resource that you've used that is under stress, it can become a point of contention, a bottleneck within the system. So it may not give you the user experience that you expected out of SignalR, and that was the whole discussion about SignalR. Then third characteristic is high availability side of things. SignalR backplane needs to be highly available. This applies on any unplanned outage. For example, something goes down on the server end where the backplane is. For example, if it's a database server that goes down, or it could be maintenance where you need to bring down the backplane. So it should be robust, it should be extensive in terms of handling the high availability side of the things. If a server goes down, it should not give you the outage on the client, and it should not stop the delivery of messages. So these are all linked in one way or another. Performance, throughput, less latency, high throughput, that is one characteristic. Guaranteed delivery, and that's again associated with if you have less throughput and high latency, it can affect the delivery, it can affect the user experience, and if something goes down, that can again affect the user experience, it can affect everything inside the system. So these are the issues that you typically would find with a backplane that you choose, such as database. So these are the characteristics that you must ensure when you plan on using SignalR for a high transaction, in a true sense, real-time application with high transaction, with mission critical data. And we recommend that you use SignalR for such applications. Alright, so that this is a diagram which talks about database as a point of contention, as a scalability bottleneck. It's a single point of failure as well, and it's highly, it's not very highly available in most of the cases. Alright, what is the solution? And from this point onwards, I'll talk about Encache as a scalable, fast backplane for SignalR, and then why is it better in comparison, or what are the characteristics, or Encache, what are the features which actually map onto the characteristics of a backplane for SignalR. So I'll quickly define what is an in-memory distributed caching system, what is being offered by Encache. Encache cache cluster is a cluster of multiple inexpensive cache servers. These are the ones which are which could be your web servers, web server kind of configuration, a very average hardware. It doesn't demand to be had to have a high-end machines. If you have a better hardware, it's better, but it's inexpensive cache servers which are pooled together for memory and CPU capacity. So you have a logical capacity behind the scenes. There are multiple servers. So this takes care of our first issue. This is going to give you less latency because everything is in memory. And the platform offered by Encache for backplane, the message platform, it's not even storing any data. It's just using a message platform similar to a PubSub model. It is actually PubSub model where message comes to the backplane of Encache through message bus, and that's going to be sent to all the subscribers. So it's going to be super fast in comparison. There aren't any database tables or any storage involved in the backend, and I'll show you in a bit. Then there are multiple servers. So you combine the capacity of all servers together because it's a logical repository. Physically, there are multiple servers, and you have ability to add more servers on the fly. Let's come back to the example. We have 10 web servers. We have 1,000 requests. We have 10,000 requests, 100,000 requests, 10,000 into 10, 100,000 into 10, and this can keep growing. And as it grows, if you hit the capacity on the backplane, such as database, it tends to choke down. But with Encache, it's designed in such a way that it linearly scales out for transaction and memory capacity. So you can add more resources, more partitions into the system, and you introduce the capacity. You linearly increase the capacity of the system. So there isn't any, it gives you linear scalability. So there wouldn't be any point of contention, any point where you hit the limit. That would not happen. It would not give you bad user experience. So less latency, high throughput is guaranteed with Encache. And then it's very consistent. It synchronizes all updates. All messages are delivered as a must because it's very reliable. There are retry mechanisms. If a server goes down, the other servers pick up. So everything is, it's a self-healing cluster. It's very reliable. It ensures guaranteed delivery of all messages. And then it replicates data for reliability as well. So that's another characteristic. But these three map onto the SignalR characteristics nicely. Distributed cache like Encache is super fast. It gives you super fast view as far as user experience is concerned. High throughput, linear scalability, and so high throughput is possible. SignalR apps need guaranteed delivery of messages, so that's taken care of, and it's highly available. Any server goes down, there's no data loss, no message loss, no downtime for your applications. You just need one surviving node, and there could be multiple nodes at any given point. So this completes our discussion around the characteristics of SignalR backplane and Encache as a perfect fit as a solution for that. Any questions so far? Please let me know. This is our typical deployment. Encache can be deployed in a central tier, and multiple applications connect to it in a client-server model. In this case, it would be your web applications, and 2 to 3 servers are good enough. So that's our typical deployment. All Windows environments are supported. 2008, 2012, 2016. It's .NET based product, so it's a perfect fit from that avenue as well, where you use it within ASP.NET applications utilizing SignalR. So it's within the same stack. All right, so that's a diagram for deployment architecture of Encache as when used as a SignalR backplane. So, and I'll just bring back this diagram right here. So you have a web form, SignalR apps, backplane. So with this backplane, instead of using a database or any other slow data source, use Encache, which is distributed in nature. So we have web servers hosting the SignalR apps. We have Encache cache cluster. It's pooled memory, linear scalability, pooled request handling capacity, very reliable, very highly available. If any server goes down, there's no data loss, no downtime for your applications. And we're using a PubSub model to achieve the SignalR functionality. So Encache gets plugged in as a server, as a backplane, and in this case, this web server is going to publish all the notifications and is going to be transmitted to all the connected clients, and those would in turn transmitted to all their respective clients. And this can be done by any of the web servers.
Question for you.
Yeah.
So can the same cache be used for sessions or object caching?
Yes. So this is a distributed cache, right? So one of the use cases is that we use it for SignalR, but that does not limit you from using the same cache for other use cases. You can even use the same cache for sessions, for view state within web forms, for output caching as well. So these are all associated features. Anything that you would like to cache for high performance, would like to avoid trips to the database. So what are the limitations that we discussed for SignalR backplane? If these are the limitations for your conventional data sources, you can very well use the same cache for those use cases as well. So yes, that's the all right. So this diagram will actually move on to a slide where we talk about some scalability numbers. We mentioned that this is a linearly scalable cache cluster, and that can be used as a backplane. So with this, you can keep on introducing more and more caching servers, and as you introduce those caching servers, it actually improves your capacity. So these are some reference numbers with high amount of transactions. You can see the linear improvements, and this is not possible with database. because they would choke down under a certain load when it hits capacity. You don't have ability to add more servers in the database layer, but with Encache, this is a dynamic cluster. You can keep on adding as many servers as you need to, and it would grow the capacity.
Quick question for you, Ron. So now that you went over Encache a little bit, can you maybe cover like what all is involved in deploying it? Like how complex is installing Encache? Are there any code changes? Can you just maybe cover that?
Sure. Okay. So I'll quickly take you guys to our demo environment and show you what is involved in terms of configuring this backplane. And as far as application changes are concerned, these are minimal changes. There's one line of code that you need to introduce where you start using Encache as a backplane. So that's our next segment, where I'll take you to our demo environment and show you how the cache gets configured, what is involved. I'll talk about some monitoring aspects as well. That's another benefit that you get with Encache. So this is our demo environment, demo 1 and demo 2 right here. So these are the two servers I'll be using. So my backplane would be using two servers within Encache website. If you go to alachistore.com, on our download page, I've downloaded Enterprise Edition 64-bit. I have brought that installer onto my demo environment. Let me just save this project, which is locally available right here. Yeah. Alright, so within our demo environment, I've installed Encache server portion. That's where I plan on using the backplane. And like I said, you can use it for other features as well. So Encache has already been installed. There's a GUI-based installer. There are command line installation options as well, and we have a pretty detailed help document available on our website. Right, so you can use that for to get started with this. And there are a few webinars that we've already done as part of this series. So that covers those actually cover all the details around installation, configuration, and best practices.
Question for you, Ron.
Yeah.
So one of the members of the audience has a question about handling multiple data centers for the backplane.
All right, how do we handle multiple data centers? All right, not a problem. We have features where you could use this on a WAN replication level as well. So whatever data which is being transmitted on one data center can be transmitted to another data center. But if it's just a requirement of having clients on two different data centers, they can all get connected to the same centralized cache tier. So one of your clients would go through latency, but that's inevitable. Other alternative to that would be that you have a backplane here, and then you have a respective backplane in another data center for its own respective clients. If these are active sites, you might want to use a bridging feature where you bridge these two backplanes, two caches together. So that's what we conventionally offer. One option is that you have a centralized cache tier used by multiple data centers. Other option is respective caches in each data center. And then third option is that you use bridge, where you replicate data and any other information between those two data centers, two caches, which are linked through bridge. So that should take care of this particular scenario. I hope that answers your question. Next, I'll talk about the configurations. I'll quickly go through this. This is a management tool. Once you've installed Encache on the server, on the client, if it's on the web servers, you can install Encache client portion. If it's in Microsoft Azure, if these are app services, no underlying VM, you can use the NuGet packages on the client end. So both options are there. You don't need to install anything. Alright, so I'll just create a clustered cache. Let's name it Signal R cache. All caches need to be named. So that's our cache cluster, which we'll be using as a backplane. I'll just keep everything default here. As part of our other webinars, we have already gone through all the best practices, all the settings that you need to do. So I'll just quickly go through these. Demo 1 and Demo 2 are the two boxes. And I'll pick a TCP/IP port. Encache communication is on TCP/IP port, and behind the scenes we're using a PubSub model. That's the feature where we have size. It doesn't even matter for Signal or backplane what size you choose, because it's not going to store anything. It's just the queue, it's the data structures which we use behind the scenes. And I'll auto start this cache so that it starts up automatically. And I don't want to turn on eviction. I want to keep everything in the cache, even if it becomes full. And that's it. That completes our configuration. So there was a question how difficult it is to configure Encache cache clusters. This is all what you need. And then you need to add the client IP where your web server is If it's not a a VM, in that case you can just specify the configs in the application app config can be linked with these settings. So two servers are configured. I'll just start and quickly test this cache cluster, and next I'll show you the client-side application changes. There was another question around it. So this is going to start my cache cluster, and after that I can connect to it. I'll first test it whether it's running fine. So view cluster connectivity shows fully connected status, and I'll open another tool called monitoring Encache monitor tool, and that's another benefit that you get when you use Encache as a SignalR. You get the full monitoring of servers and clients, whatever is going on, you get notified about it, or you get complete monitoring of the system. Alright, so I'll just test this. It's not case sensitive, so I don't have to worry about it. So I'm just going to test it from my web server as far as connectivity is concerned. I'm able to connect to both boxes. Let's see if yeah, there you go. So we have activity coming in, and we have dashboards being populated as well. So we have healthy cache connection from both servers as far as client connectivity is concerned. Alright, so we're good. I'll now show you the application changes which are needed, and let me know if there are any other questions around that. Alright, so next I'll show you all the application related changes. For example, what we've done here is we've downloaded a sample application which comes which I've copied from one of Microsoft tutorials. So this is a conventional chat software, right? So it is using SignalR, so I'll run it by default, and then I'll show you how to hook this with Encache resources. So this is going to start this chat room application. Let me just stop this because I think there were a few instances previously running, so let me just, I may have to change the browser in a bit, but let's see. So I downloaded this sample and I ran it for by default I just ran it. Let's see what the application looks like, and then we'll plug in Encache and I'll show you all the steps that are needed. It's pretty straightforward. It does not involve any extensive coding as far as applications are concerned. It would just allow you to connect Encache to it as a backplane, and you can see the messages being transported. For some reason it's awfully slow, but there you go. So that's the application. I'll just add myself as a user. Next user, I'll quickly use Adam, and at this point I'm Ron as well as I'm Adam, so I hope Adam is okay with it.
I'm okay with it.
Yeah, thank you, Adam. Right, so that's the second user. Now we can chat, and notice that I will just say hello from this window and it will pop up on this window as well. So that's the beauty of SignalR, that whatever messages that you type, those are going to instantaneously shown on both windows. So new content is being pushed, but this content was pushed by this server, but it got shown on the client, right? And then vice versa as well. So you have two web servers. In my case, I'm just using one web server at this point, but in your case, if you have two web servers, there has to be a delivery, and that's where you need the backplane. So once we deploy it in a web form, you need a backplane, and I'll show you what are the steps which are needed in order for Encache to be used as a backplane. So I'll talk about this step by step right here. Okay, so first thing that you need is to introduce a NuGet package. So if you go to the NuGet packages, there may be some installed NuGet packages because it was downloaded from Microsoft. So you need to look for Encache, search in the online NuGet.org, and then pick alachisaw.encache.signalr implementation of it and click install. That's it. So this would introduce some resources inside this project. Check OK on this, and that is what you need as part of it. And this README document explains what we need. It talks about Encache documentation. It talks about resources which it added. There is encache.signalr assembly and then signalr core dependencies. If I show you the references, that's the library that it added. And this consumes all this actually exhibits all the functionality that you need when Encache used as a signalr backplane. And then it also added some other methods. And what else you need? You need one line of code to be introduced. That's it. That is the line of code that you need to introduce. And in this line of code, you can actually pass on the name of the cache and get connected to it. So before I actually make any changes, I wanted to show you the signalr, the method. If you go to the chathub.cs, this is the method, client.all.add new message. And if I go to the views, there is a controller. There's a chat.cs HTML, and here you're pushing this functionality through signalr. So this is the method which is create a function that the hub can call back to display message. So this is a method, right, on the view, and this is being called from the hub itself, from the server itself. It's a server invocation, client method invoked from the server. Alright, so coming back to this, so all I need to do is, now that I have NuGet package added, I'm going to include a namespace, and I've already included the reference for it, and then I'm going to copy some code to load some configurations. Actually, let me just add the config section here. So with Encache, you need to add this tag into your web config. These values can be hard coded within the code as well, or you can read from your app config as well. So you need a cache name. In our case, it's signalr cache. Again, it's not case sensitive, so signalr cache is good. And then the event key. All the applications which are connected to web signalr framework, you need to come up with the same event key. So if this is a chat system, so all the web servers hosting this application should provide the same key. So that's how we get notified that these messages belong to certain particular application. If there are multiple applications using the same cache, that's when this is going to help, that you don't mix messages between different applications. Alright, so next I'll just come here and copy some code to read my settings. And again, that's again very simple. I've defined a cache and event key, read the cache from the cache settings, read the event key, and then I need to set up a connection to Encache. And like I said, there is only one method that you need to call, and that's right here, global host.dependency resolver.use Encache, and it takes two parameters. There is a cache name and event key that we're specifying, that we've read from the configs, or you can just pass the scale out configuration section, right? So that's it. This application is now good to go. It's automatically going to use this cache right here. The name of the cache is resolved to the corresponding servers with the help of our client.ncconf file, and that's already configured because we added this box as a client. So as far as configurations are done, these are complete, and this completes your server-side configurations and client-side configurations as well. So inside the config, there is a client.ncconf which actually maps the signalr cache to the right servers as well. I'll run this application one more time. So if I come back here, everything looks good. Now this application is going to be used as a signalr backplane. So now this application is going to be utilizing Encache as a backplane. I'll spawn a few instances of this application and show you the request handling on the server end as well.
Quick question, Ron. So, excuse me, is there a way to not have a dependency on the client file that is present in the Encache folder?
Yeah, you can use the NuGet package, which actually consumes the client cache, the client.ncconf inside the application project. The other option is to use init params. So the IP addresses and those configurations can be specified directly in the code. But that would just increase more, actually that would introduce more code into the application architecture. But yes, that's possible. You can completely get rid of client.ncconf. One option is to introduce it into the project. The other option is that you provide all those configurations yourself. Alright, so I'm going to log in. That's my chat. I'll just start another window, considering that this is another user on another web server, right? So same application deployed here, and I'm again going to use Adam as a second user and send messages here, and now it's right. So I can just send dummy messages and keep doing that. And behind the scenes, if I come back to the server right here, there is one item, and this is going to be exactly the same item that we used. This is just a notifier that this message is in regards to the chat event key. And if I quickly show you this while I have, for example, let me see if I can put some request here, and at the same time keep an eye on this, and at the same time I'll just type something here. You would see requests per second showing some activity. Oops, I need to be very careful with this because it's difficult to show two windows at one go, but I'll try my best. Alright, so there would be some activity. Hello again, and you would see requests per second here. There you go. So that actually shows that there was a request onto the server, and then there were two requests because one message got received and it got transmitted to all the other clients, and that actually shows you. And at the same time, all the messages are shown to both the connected clients. So that's something that completes our implementation. Let me just quickly reiterate. What you really need is create a cache by downloading Encache, installing it, create a cache. You can also monitor it as needed, right? So all the monitoring aspects are covered, and then you set up NuGet package, include the library, and then call this line of code. That's all what you need in order to get started, or that actually completes, not actually getting started. SignalR implementation gets complete at this point. So please let me know if there are any questions. Behind the scenes, we're using our PubSub model, so the Encache can be used as a message queue other than SignalR as well, and that's what we're using behind the scenes. So it's a PubSub. So there's a channel where your clients get connected, they subscribe, and then messages are published to that channel. So that's what we're using behind the scenes. And it could be between .NET to Java application, or it could be .NET to .NET or Java to Java application. And for SignalR, we're using it for .NET to .NET. And monitoring and other aspects we've already covered. And like I said, Encache can be used for ASP.NET Sessions, view state, output caching, and data caching as well. So anything where you see bottlenecks, it can be used as a caching store as well. Fast, reliable, very highly available, and then very scalable as well. So let me reiterate, this completes our technical presentation at this point. Let me just give you a quick summary of what we've discussed, but please let me know if there are any questions at this point.
I have a question for you. Can you maybe go over where some documentation might be as far as all the configuration and the details that you just covered? It was quite a bit.
Very good. Okay, so basically within our product library, if you go to documentation, that's where you should find most of the things. For example, administrator guide, command line tools, management guide. But if you go to the programmer's guide, within the programmer's guide we have, if we right, so within the programmer's guide you have server-side API programming, client-side API programming, so that should cover ASP.NET and typical features as well. So here we have the SignalR. So this should take care of all the details that we have. So we're using custom events, we're using item versions, and this also talks about using Encache extension for SignalR. So that's that's pretty much it. So it helps you use the SignalR, the NuGet package, what gets installed, what are the configurations, and what is the line of code that you need to change. That's exactly what I copied in today's webinar as well. I picked Microsoft sample, and that sample actually gets installed with Encache as well. So if you go to Encache samples .net, we have a SignalR sample which is available right here, SignalR chat. So this is the same sample, but I picked a fresh sample from Microsoft website and then I equipped it in front of you. So all the documentation is going to be made available. Alright, so let me just quickly give you a quick summary of SignalR and all the details that we discussed, so that for the sake of completeness, this is going to complete the webinar process. So we discussed ASP.NET SignalR. We talked about its architectural details, industries, use cases, scale out issues, solution offered by SignalR, what are the characteristics, and that's the backplane. What are the characteristics that must be in the backplane, and what are the issues with databases or conventional data sources used as a backplane, and then Encache as a solution for that. And then we used a fully, we gave you a full hands-on presentation on how to create a cache, how to set up the environment for backplane, and then what are the application side changes that you need to make. So that completes our presentation at this point. Please let me know if there are any other questions.
I don't see any questions. I'll give it another minute if anybody has any questions. I will keep monitoring it, but let me say, thank you for everyone for dedicating some time to us today. We hope you enjoyed the show. Next steps, if you're interested, Ron showed you on our website, you can download and use our enterprise product for up to 60 days. If you are interested in a one-on-one demonstration with Ron or one of our other solutions architects, please reach out. We'll be more than happy to spend some time with you and go through Encache in detail. If you want to have a technical session to discuss your use case and how Encache could possibly help, please let us know. We're here to help, and we'd love to chat and talk shop. But yeah, if there's no questions, I guess that'll do it for this afternoon. And again, we thank you. Thank you for your time.
Thank you, everybody. Thank you.